Hello. Okay, welcome to Python Challenge for All. The first column says 147. First row says 1, 2, 3. This is good enough. Okay, so maybe you know how to do it from here. The next thing, calculate the rest in here and finish all. So we can do either clockwise or counterclockwise. For example, in this case, it's easy to do in counterclockwise. And now we have everything in place. Okay, good. Hello. Okay, welcome to Python Challenge for All. Okay, nice to see you again. So today, as I promised, I will tell you the hints for solving games. So last time, in lesson 76, we generated solvable games only. We found the way to determine if a game board position is solvable or not. And the key is inversion number, the number of elements that are out of their natural order. And if the parity is even, that's solvable, otherwise unsolvable. Okay, and we check all the time that inversion number parity remains the same, whatever movement we make in sliding games. Okay, so today's topic is how can we solve a solvable game. So let's try that. Let's quickly go back to the code and see if what we did was correct. Okay, so we made the new game generation function so that it tries at least 10 times. Yeah, just 10 times, at most 10 times, generate a game and shuffle the game so that we randomly generate a game and check its inversion number. If it's even, it's solvable, so break from the loop and initiate, go back to the main loop. Otherwise, if it's odd, go back to generate next game and repeat it until we have solvable game. If it's 10, the possibility of finishing all the loops without making any solvable game is, as you can guess, it's one time in 1024 times. Okay, so it's very unlikely. So let's quickly to see what we do today. So hints for manually solving 8 games. So for example, taking this example, I tell you how to solve it manually. Okay, so let's make this game. Let's So in the new game, we make after randomization, we write it here, any game we want. So here, let's take this example. Let's quickly remove it and 8, 4, 5, what was it? 84532076671. Okay, 8453207 and 671. Okay, so this is what we have. Okay, the good news is that it's okay game. Okay, the inventory is 18, so it means this should be solvable. So let's see what we can do about it from here. So in the slide, I say next step is move 1 to upper left corner. Okay, so here I want to move this one to here. Okay, maybe we can do it by, say, moving, for example, like this. Okay, so here we have 1 in the upper left corner. Okay, what's next? So next is move 2 and 3 to the right row, the first row, like this. So to do that, maybe we can first determine where to see where the 2 and 3 are, a little different from this. So whatever way we can do, yeah, okay, I know I can do like this. Okay, good. So now we have 1, 2, 3 in the first row. Okay, what's next? Next is move 4 and 7 to the first column, like this. Okay, so 4 and 7 are here, a little different from here, but say what we can do about it. So it's a bit tough. Let's see. For example, how about this? Okay, now I have kind of good news. So, like this, I hope you can do the right thing about the step 3. Move 4 and 7 to the first column. So the first column sets 1, 4, 7. First row sets 1, 2, 3. This is good enough. Okay, so maybe you know how to do it from here. The next thing, calculate the rest in here and finish all. So we can do either clockwise or counterclockwise. For example, in this case, it's easy to do in counterclockwise. And now we have everything in place. Okay, good. 49 steps, so it's not actually the smartest way. But anyway, we know we can do it. So let's try another case. I'm not sure I can do it very easily. So let's randomly generate a game and let me solve it and show it to you, demonstrate it to you. So again, let's comment this out and let the program randomly make it. So as we did last time, so it first make this game whose inversion number was 13, meaning the parity is odd. So it's unsolvable game. So it's do it second time. And in the second time, this made it. And the parity is even, so we can solve it, theoretically. Can we solve it? Maybe you can. Of course, it's different from yours. So maybe you can put this in your code and try it. So the first thing is, as I showed you, move 1 to the upper left. So maybe we can do it like this. I don't know. Yeah, maybe this is good enough. Okay, move 1 to upper left. And then move 2 and 3 aligned in the first row. Okay, how we can do it? A bit tough, maybe? This is not what we want. So how about this? This is not good. So, how about it? Okay. No, it's not. So this is not, this is a bad example of how we move the panels. This is good. This is not good at all. So maybe you'll get used to it sometimes. I don't know. I hope you will sometime later find out how to do it correctly. But anyway, I managed to make the first row. Okay, and then do the first column, 4, 7. So this is upside down. Maybe we should do it a little with pain. This is not wise. Okay, somehow I did it. 1, 2, 3, 4, 7, and now it's kind of automatic. Okay, 148 steps, which is far from good movement. As I will tell you later, all 8 puzzles can be solved in 30 steps at most. So this is far from perfect. But anyway, I made it. So this is, maybe you can try yourself. This is the hint for solving 8 puzzles, all solvable games manually. Okay, I hope you will get used to it and come back next time for further enjoyment of sliding puzzles. That's all for today. See you next time. Bye bye.